Okay, welcome to Code to 2025, day 1. And we need to spin a dial lock based on some numbers. Every time we get to 0, not going past 0, specifically when we finish on a 0, we count. And the number of times we do that is the answer. This is some modular arithmetic. And when we go left, we're going to go negative. When we go right, we're going to go positive. Max number is 99. And we start at 50. So the first thing to check is what modulo does on negative numbers. Because there are two different ways of doing modulo on negative numbers. The first kind of does what, well, I suppose it depends on what you expect. Behavior for negative arguments is based on truncating division, whereas modulo should be based on flooring division. So let's go see what that looks like. Let x be minus 5, and let y be positive 5. We'll print line positive mod, don't need that, pos mod is that, neg mod is that, and we will just start doing this the wrong way around. We'll do y mod 4, let's say, which is going to give us 1, and x mod 4. Okay, so we're still doing a positive number. So is it going to say minus 1? And it does. So that means that in this scenario, if I start at 4, let the change be minus 9. Expect is going to be, so we're going to go 4, 3, 2, 1, 0. It's 4 down. 99, 98, 97, 96, 95. So we're going to expect 95. And we're going to print line. Mod of res is that, expected that. And what we're going to do is, for a moment, we're just going to do start minus change, start plus change. Change is already negative. Mod 99 and expect. And let's see what it does. So it's minus 5. Well, that's fine because we can probably just do 100 plus that. For negative numbers, we can do 100 plus that. For positive numbers, we can't. Yeah, okay. So it's possible that what we'd actually want is the modulo operator. So here they're saying minus 5 mod 3 is positive 1. Which means I think this also doesn't do what I expect it to do. So we're just going to have to do this manually. But that's fine. Right, first thing we've got is a list of strings. So we are going to parse string, s is ref stir, and we're going to give it an actual I size, because what we're going to do is we're going to make it positive or negative. And all we're going to do is we are going to let val be s and 1 dot dot parse I size and wrap, and then we'll match s 0. So we're taking a string slice. I'm going to say if it's left, then we take minus val. If it's right, we take plus val. None of those other ones, please. Anything else, going to be panic, invalid direction. Can't index a slice. Fine, we'll match on chars nth 0. Unwrap. Wrap. Better. Fine, yeah. Happy? Perfect. We can test that briefly. Goodness me, I can't type. Test parse string. Let A be equal to L4 to string. Let B be R2 to string. Assert equals parse string ref A should be -4, and that is correct. Okay, part 1 has failed, but that's fine. What we care about is that parse string succeeded. Great, so we can ignore you for now. And let's take a start parameter just in case. It's going to be an iSize. We're going to return. Should technically be a usize because it's never going to go negative. And we're doing negative stuff manually anyway, so that's fine. What are you unhappy about? Oh, right, yes. Part 1 starts at 50. 4s in input. We are going to let val be equal to parse string on s. If val is less than 0, then what I want to return, let mute count is 0. Pos is mute pos. Cool. If val is less than 0, count plus equals 100 plus val, right? That's going to effectively tick us around the clock. So if count is at 3 and value is -5, what we expect to end up at is 2, 1, 0, 99, 98. So we're going to get 103 minus 5 is 98. Else, we're just going to do count plus equals val, val, and we need to store this. And then count is, in fact, let's do it in one line. Count plus val mod 99. Okay, so if we get to mod 100, yes, it's mod 100, because 99 is a valid number, which is why this is 100 here. Okay, if count is exactly equal to 0, then this isn't count, this is pos. If pos is exactly equal to 0, count plus equals 1, and return count. What don't you like? Usize and iSize, which one is pos? Is a usize? Yes. Okay, let's just find all usizes and turn them into iSizes. That's just going to make everything much easier. Are we happy? We are not happy. What the fuck are you there for? And down here, part 1, input. And does the test also start at 50? Yes, it does. Right, we've got it wrong because on our inputs, test bar string can go away. On our inputs, we are getting 1 instead of 3. So, this is going to be fairly short, so we can actually go, let's debug there. And we can see what our position should end up as. So our position goes to 82, correct. Then it goes to 152. How did we end up at 152? We ended up at 152 because I didn't check to see if the value was going to go negative. Right, okay. So, actually what this needs to be is just going to be pos plus equals val. If pos is less than 0 at 100, otherwise mod 100. It's not the prettiest way of doing it, but I was about to say it works. It works. Cool. 698. What fresh hell is going to cut? Ooh. It's interesting. It doesn't say if it's going to be lower or higher now. Right, so there must be some odd edge case. Passes the test. Do we go all the way round on both ways? So we start at 50, we go left to 82, that was fine. Go left to 52, then we go right to 0. We aren't going over 0 yet. Then we go over 0. Then we go left back to 0, we go left to 99, we go left again to 0, we go right. We go right. What is going on? Hoisted, failing the first corner. First hurdle, there we go, that's the expression. Am I giving it the right input? Is probably the good thing to start with. Real on day 1 on base steer, which is indeed 2025. It's coming out with a number, so it's parsing it all correctly, so that should be fine. We definitely start at 50. Yep. Number of times the dial is left pointing at 0 after any rotation in the sequence. And it's not that you just have an issue going through because the tests pass. What if I add on to the test data? So where do we end up after the L82? We ended up at 32. So if I add L32 and run tests, right, this should fail because it should be 4. Yeah, okay, cool. Or if I go right by 68, then we got 4 again. Okay, so going left to 0 and going right to 0 both do what is expected. This is very bizarre then. Let's just go and inspect. So the input size is big, what we expect. Position is 88 after an input of 38. So yes, that's fine. Let's continue on to, so now we've added 2, so we should be at 90, yeah. Left 2, we're back at 88. Right by 25, 88. So it's going to be 12 to get to 0, and then another 13, so far so good. Well, this is awkward. What is going wrong? We're not getting any panics from weird directions, right? So we're getting valid directions each time. So I guess it's possible that's an inclusive range, and indeed that appears to be working fine. What am I missing? This is very awkward. I know. I'm going to have a think, and I will get back. Okay, so it turns out it was my weird, dodgy remaindering. And it also turns out there is a function that does exactly what I wanted, called rem Euclid. So here it is in the docs. That now leads to the answer. Well, I hope it is anyway. I've not actually checked this answer, so let's see. Great. Awkwardness over. Door won't open. You're not known answers. Rolling snowballs for your snowman. You find another document. Junior, please use password method. You're actually supposed to count the number of times any click causes the dial to point at 0, regardless whether it happens during a rotation or at the end of one. Right. Okay. So the new password is 6. So let's go grab test part 2. Part 2, we're still starting at 50 and we're getting a result of 6. Great. Cool. Right, so broadly speaking, part 2 is going to look a lot like part 1. We have a count, and we look at our input. Now I do need to do some positives and negatives. So if val is less than 0, and if val is less than 0, and pos plus val is less than 0, count. Otherwise, if val is greater than 0 and pos plus val is greater than 99, or greater than or equal to 0, count that one, then do the maths and ignore that. Cool, test passed, although the test did pass before, which is interesting. 2,526 is too low. Oh, so now it is telling me that it's too low. That's interesting. So again, passing tests, something is wrong. So let's work this through. Oh, well, it could stop at 0, couldn't it? Right? if pos plus val is exactly equal to 0, so if we are going left, we're going negative, we can land on 0, or we can go past it. If we are going to the right, we just need to make sure we go past 99. Hopefully that still passes test. Didn't. We end up with 8. Hang on. I fiddled my test data, didn't I? Did I put it back? I did put it back. Does this need to be an else if? No, I don't. I mean, it shouldn't need to be because value can't be both of these things. Is it possible to get a 0? Presumably it is. In which case, as an edge case, I haven't counted. Now that doesn't change the fact this test isn't passing, but let's see what result we end up getting. Just in case. No, still too low. But the test is too high. If the dial pointing at 50, a single rotation like R1000 causes the dial to point at 10 times. Ah, right, okay. Yeah, okay, that's a useful thing to know, isn't it? So, count plus equals val mod 100. Value is negative. Do I still have my playground up? So if it's minus, let's get rid of those. If we start at 50 and we change by minus 500, then we're going to go past 0 for every 100 turns. So we should get 5. So what I want is going to be change mod 100. Is change mod 100 going to be negative? Why is it 0? Minus 500. Mod 100. Yeah, okay. That was silly of me. I want to divide by 100, which gives me minus 5. Fine. If it's 501, that's still not good enough. It would need to be if we start at 50, then minus 550 will be 6 turns. So first off, we are going to do count is equal to minus val mod divided by 100. Let's count val divided by 100, and there's still a case we haven't got here. So presumably this is still going to make tests go absolutely haywire. But we're down to 0. Okay. We need to add 1. Oh, it's exactly that. It's 1. And is it the same that way? So that still gives me 8. And I can get not 8 if I make that strictly less than 0, which I think is wrong. Why would that not be right? If we're going left, and we end up at anything less than 0, we count it. But I mean, well, let's run it and see what happens. That's too high. Oh. I can actually get that edge case here, can't I? For val plus pos. And somehow that works. What is going on? Another break, I think. Okay, so I think I've worked out what the issue is. So first off, I got rid of the if it was already 0 and we don't move, add 1, because, well, A, it didn't make a difference, and B, that doesn't count as moving through 0 again. So that was out. So the issue is, imagine you are at 50 and you get a right 101. Well, this code is going to take you, so you're going to go to 151, and this code is going to add 2 to count. But actually, you've only gone past 0 once. So, I think we go back to this. There's actually an easy way of doing this, right? Which is, let's comment this out for a moment. And I think it's just, if val plus pos is less than 0, count plus equals minus val, or minus, in fact, count minus equals val over 100. No, that's confusing, right? Let's do plus equals minus val over 100. Okay. Else counts plus equals val over 100, right? So else if val plus pos is greater than 99. Okay. So basically, if that's going to be fine if we do a full loop. So what's the situation I want to... But then I also want to know if val rem Euclid itself with no, if abs val is greater, if abs val mod 100 is greater than pos, then I think we add 1 on as well. Okay, so basically if we're in this situation again, we are going to add 1 from going right 101 to get to 151. Then we'll say, well, actually, the absolute value mod 100, well, that's going to be 1, Is 1 greater than 50? No. So that's not going to take us round another bit of loop. Now this is actually wrong. It needs to be, is it greater than 99 minus pos? Okay. And I need to check if that should be 100 or not. So if you are at 0, you would need 100 to add on 1, which is going to happen here. So you need to make sure, so if this takes you to exactly 99, it needs to be greater than 100, I think. That's still not going to do it, is it? So if you're starting at 0 and you go right by 101, that does not add on 2, that only adds on 1. If you start at 99 and you add on 101, then you need to add on 2. So that's where we're starting. Which means that this would need to be greater than or equal to, so it needs to be greater than 99 minus pos. I think that covers every case where it's not. Well, let's look at the other side. If you are at a value of 1, you need to add on precisely 99. Which means, or 99, yes, if you're at 1, you need to add on precisely 99. If you're at 0, you need to add on precisely 100. Why is this so hard to think about? One moment, please. Please, dear watcher. Okay, so I think I've got it. If you are going left, add 1 on for every time you go 100 round. Then, if you are going to go left by more than your current position, but not up to 100, so if you're at 5 and you get given a minus 105, you'll get 1 from here, and then you'll end up with a 5 here, which will be greater than or equal to your current position, so you add 1 there. If you're going right, add 1 for every time you go around 100, and then you need to add 1 for every time you are moving at least the difference between 100 and your current position. So if you're at 98, then you need to move at least 2 to add up, and then do the actual move. So, tests pass. That's still a pretty high number, but I think the previous one was like 6.5 something. No! It's so annoying that the tests pass, but the solution doesn't. Let's try sticking this actually in. R1000 is going to add on 10. Right, so if I go to test data and I add the first move as being R1000, the test should be 10 too high, so that is fine. Okay. Presumably L1000 is going to give me the same. Yep. And from here, where do we end up here? We point at 32. So from here, L1000 here is still going to give me another 10. L1033 should take me to 17. It does. L1032 should also take me to 17. It does. R1000 should take me to 16. It does. R1060 remains at 16. Yeah. R1068 should take me to 17. There we go. Which it does. So this appears to be behaving correctly. I don't know if it's too high or too low. Is there anything else in here that I've missed? I think I need to have a little think again. Okay, some sneaky, subtle, little insidious bugs that I've took a bit of typing and examples in my head to figure out. It doesn't actually matter, because we're doing this maths anyway, all this, it doesn't actually matter. You don't need to check that the whole thing goes below 0, because we're kind of accounting for it anyway. And I think there was like a weird edge case where checking to see if it goes below 0. Well, basically, I mean, let's check I've got the right answer first, and then we'll see. 46 seconds left to wait. So if we go back to what it was, it's this: if val plus pos is less than or equal to 0. And I think actually it was literally just how far am I going back? I think it's literally just that it can be less than or equal to 0. Yeah, I think that was it. If this is right, then that was it. But nonetheless, all of these checks are just irrelevant, right? All we need to know is if you are less than 0, do this maths. Otherwise, do this other maths. Because we're accounting for the fact that it might or might not tick over anyway. I don't know if that's been the relevant amount of time. That was far more painful than it ought to have been. But that is 2025 day 1.